Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student, here I am going to talk about the consideration of solutions. Before I start with the consideration of solutions, let's have a quick review about the previous lecture. So, as I have said, substance can be divided into pure substances and mixtures. Pure substances, like elements, elements are those who are in periodic table, like hydrogen, iron, carbon, sodium, potassium, rubidium, etc. And compounds usually consists of two and more elements, like water molecule, carbon dioxide molecule, acetone molecule, sugar molecule, etc. Mixtures are divided into homogeneous and heterogeneous. Homogeneous mixtures like alloys, solutions, and gas mixtures. Heterogeneous are like suspensions and colloids. That's what we have explained in previous lecture. Let's start with today's lecture. Okay, concentration of the solution is a measure of the amount of solute in a given amount of solvent or solution. If you have, for example, a cup of water and you put on it some sugar, so you have a solution that contains a solute sugar. You want to make it a numbers, so you can know how much sugar exactly you have in the water. So you do calculations, you calculate molarity. It will give you an idea that to what extent this solution is concentrated, because as you know, as you put more solute, you will get the more concentrated solution. If you put 1 gram of sugar, then you put 3 grams of sugar, the solution that contains 3 grams of sugars is more concentrated than the solution that have only 1 gram of sugar. To make it number, of course, you should have some laws. Here we have molarity and molality, which is the topic of today's lecture. Molarity is mole of solute per liter of solution. That is amount of solute by mole divided by volume of solution. You should already know what is the number of mole, how we can calculate the number of mole. Okay. Number of mole equal mass over molar mass. Yes, very simple. You have you should know this law. Let us have some practical examples. Yes. In this solved example, you have 3.5 liter of solution that contains 90 gram of sodium chloride NaCl. What is the molarity of the solution? Okay, before you start with any mathematical example, first of all, you should analyze it. You should know what is given and what is unknown. So the given is the mass of NaCl and the 3.5 liters of solution. The unknown is the molarity of NaCl. Here you have the mass of the solute. We have the mass of the solute, which is 90 gram per NaCl. And molarity equal to mole of solute by volume of solution or solvent. So here we have 90 gram of NaCl, we will convert it into mole. So mole of NaCl equal to mass, which is 90, divided by molar mass. You should know how to calculate the molar mass from your previous study. Molar mass equal to sum of atomic mass. Atomic mass of NaCl, atomic mass of Na, let us take it from the periodic table, is 22.99, which is roughly equal to 23 gram per mole. And for Cl, let us derive it again from the periodic table. Cl, here we have 35.45. Yes, 35.45 gram per mole. Yes. So molar mass of NaCl equal to atomic mass of Na, which is 23, plus atomic mass of Cl, which is 35.45. Simple summation, 58.45 gram per mole. Okay, I put here 58.45. Simple division. We say, let's have calculate. I have calculate with me. 90 divided by 58.45 equal 1.5. So the number of mole we have 1.5. We come here again, equal to, yes, 1.5 divided by 3.5. 3.5, we get molarity. Let's check the volume before calculation. Yes, 3.5. 1.5 divided by 3.5 equal to 0.4, equal to 0.4. Yes, here we have 0.4. That's, you can calculate molarity examples. Okay, problem B. You have 0.8 liters of 0.5 molar HCl solution. How many moles of HCl does this solution contains? Here you have the molarity and the volume. So it is very simple. We have molarity equal to mole of solute divided by volume of solvent. Yes. Here we put 1. Then mole equal to molarity times volume by liters equal to, we have molarity 0.5 and we have volume 0.8. We get 0.5 times 0.8 equal to 0.4, equal to 0.4. 4, hop, 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 hop. Yes, 0.4. Let's check it here. Yes, 0.4. Yes. Here is another example. To produce 40 gram of silver chromate, you will need at least 23.4 gram of potassium chromate in solution as a reactant. All you have on hand is 5 liters of 6 molar potassium chromate solution. What volume of the solution is needed to give the 23.4 gram potassium chromate? Okay, again we will analyze it. What we have is volume of solution, which is 5 liters, concentration of solution, which is 6 molar of potassium chromate, mass of solute of potassium chromate, and mass of product, which is silver chromate. The unknown is the volume of potassium chromate. Very simple. First of all, we will, as in the first example, we will convert the gram of solute of potassium chromate into mole. Okay. Then we will have, if you have the molarity and number of mole, we can calculate the volume. Try to derive the molar mass of potassium chromate. Try to derive the molar mass of potassium chromate, because here you have 2 atom of potassium and 4 atom of oxygen. So you will divide the atomic mass of potassium by 2, and you will multiply the atomic mass of potassium by 2, and you will multiply the atomic mass of oxygen by 4. Let us solve this practice example as well, and we'll finish talking about the molarity. Actually, I want to give you a general rule that it may help you to calculate the to easily calculate the unknown in molarity law. Let's start here. Molarity equal to mole over molar mass. Yes. Mole equal to sorry. I have mistake here. By volume. Yes. Mole equal to mass over molar mass. So just I put this here, I get molarity equal to mass divided by molar mass times volume in liters. Sometimes the volume may be given by ml. So in this case, I get mass times 1000 divided by molar mass times volume if given by ml. Now let's solve this example. Let's take a picture from it. Yes. Here we have 5.85 gram of Ki, okay, dissolved in enough water to make 0.125 liter solution. This is now the unknown is what is molarity. It is molarity. So very easily I can use this law. I can use this law. Why? Because the volume is given by liter. So very simply I can say molarity equal to, I have mass 5.85 divided by molar mass of Ki, K equal to 39 gram per mole, and I equal to 126.9 gram per mole. Summation, simple summation, I get 1166 gram per mole. So I put here 166 times volume is 0.125. Simple algebra, I get 5.85 divided by 166, 0.125, 0.281. So molarity equal to 0.281. Yes, here you have calculated the molarity. Try to practice with these two examples at home as well. Okay, let's start with molality. Molality is very important because you will need it when we talk about the colligative properties of the system, depression of freezing point and elevation of boiling point. So molality is like the molarity, except we divide the number of mole of solute by the kilogram of solvent. Instead of volume, we use kilogram of solvent. Okay, one of you may ask why we use the kilogram of solvent here. Okay, actually when we deal with the temperature, the volume may change. When we heat the solution, the volume may expand. And so there will be error. If we calculate the molarity, we'll get error. Instead of that, if we measure the kilogram of the solvent, for example, take water. If you have 1 kilogram of water and you put it in the fridge, on the freezer, after 24 hours, you will get the volume of the 1 kilogram of water bigger. Okay, but if you measure it again by the balance, you will find that 1 kilogram again. The kilogram will not be changed, but the volume will be changed when we deal with the temperature. That is why we use molality when we have used the temperature when, like in the elevation of boiling point and depression in freezing point. Let's look at some examples. A solution was prepared by dissolving 70.1 gram of sucrose, table sugar, in 1 to 5 gram of water. Find the molar concentration of this solution. Okay, again the noun or the solute mass, which is sucrose mass, 17.1 gram, and solvent mass, which is 125 gram of H2O. The unknown is the molar concentration of C12H22O11, which is sucrose. Let's do it here. Like molarity, we can say molality equal to mole of solute divided by kilogram of solvent. Yes, as you know, again, mole equal to mass by molar mass. Molar mass. So we can say molality equal to mass of solute over molar mass of solute times kilogram of solvent. In some examples, you may have gram instead of kilogram, so you can write molality small m. Actually, molality is denoted by small m, and molarity is denoted by capital M. Do not forget it. Equal to mass divided by molar mass here we put 1000 as a conversion factor between kilogram and grams. Here we put the gram of solvent. So we can say molality equal to, let's have only number here. The mass is 70.1 gram. 17.1 gram times the solvent mass is given in gram, so I put 1000 here. I use this law. And the molar mass of sucrose actually you can calculate the molar mass of sucrose by multiplication of 12 as atomic weight of carbon and 22 by 1 as atomic mass of hydrogen, and 11 times 16 as atomic mass of oxygen, and then you make summation. Then you get 342 gram per mole. 3.342. Here I have 342 as a molar mass times how many grams I have of solvent. I have 125. I put here 125. Then I get 17.1 times 1000 divided by 342 divided by 125. Yes, I get 0.4 molar. from this example, the answer is 0.4 mole. Yes, here you are. 0.4 molar. Here is the answer. Here you have another example. Try to solve it without looking at your textbook. Then compare your answer with the answer found here. Okay, students, thank you very much for your listening. Inshallah, in the next lecture, I will start with the chapter 2, and here, as I said, we will not solve questions because this chapter is not included in Vizari exam. See you later, inshallah.